Okay, this is lesson 6. This is a division concept. It's a support lesson because in your previous grades you have worked on division. So I'm just trying to refresh it in your brain. And then it is a 6th grade standard to know how to divide well with large numbers and be really good at it. So the wording they use is to be fluent at long division. So I want to take that in steps and build our way up. If there was any pieces that you struggled with before, I want to help you with that now in a simpler division concept sort of a thing, and then build our way up in the next several lessons. So the next several lessons will deal with division, and we're going to build on top of this. So make sure you're very, very clear on what this means and how to do it. Go ahead and copy down the title into your notes and push play when you're ready to begin. So how do you know when you need to divide? There's a couple of key factors that will help you understand when division is needing to be done. And be sure you're really aware of these, and these will need to be copied down into your notes. You know by now that I'll probably be asking you, why did you choose to divide, or why did you choose to multiply? And so here's some help in understanding when do you divide, or when do you multiply, or something like that. So division is the opposite of multiply. As you've been learning in the last couple of lessons, that multiply is the shortcut for repeated addition. If you're going to add things together add a number together over and over again, it's faster just to multiply it together. Well, division is the opposite of that. If you're going to cut things down repeatedly or subtract repeatedly, then you would be doing division. Multiply makes numbers become bigger very quickly, and division makes things become smaller very quickly. And so like I said, division is subtracting repeatedly. So if you find yourself in a position where you have something to figure out and it's going to require that you subtract repeatedly, then you would divide. Here's an example. Let's say I have $50 to go to the movies, and each movie ticket is $10. So how many people can I take with me to the movie? Well, that would require for me to say it's $10 to take you, then it's $10 to take Sam, then it's $10 to take Johnny, then it's $10 to take Rosie. And if you notice, I am subtracting the same number repeatedly over and over again. When you find yourself subtracting repeatedly the same number, that's division. So you would just say, instead, when you start noticing that repetition, you'd say, oh, okay, well, let's just do 50 divided by 10. And that will tell me how many people I can take with me to the movie. So anytime you're going along and you notice that this is going to require you to subtract repeatedly the same number, divide. It's a shortcut. And finally, division is also used when you are going to split or share something equally. So if I have a candy bar and I need to share it between 3 people, then I would be dividing. So splitting or sharing equal, or if I had, I guess in this case, since we're doing whole number division, instead of dividing a candy bar one item into smaller pieces, that gets into more of our fraction stuff. Let's say I'm dividing 10 candy bars amongst 2 people. How many candy bars are each of us going to get? Those sorts of things, when you're sharing things equally, is division. Be sure you have this information, and this information written into your notes, so that if you're wondering what type of math you need to do on a problem, you can kind of refer back to this in your notes and know what needs to be done. Push play when you're ready to continue. Okay, so as a brief dusting off of cobwebs for you, I'm going to do an I do that's a very simplistic problem, 12 divided by 3. And this is probably something that you could do in your head, most of you. But we're going to go ahead and use that standard algorithm that you learned for long division so that you can take things bite by bite. Remember the waffle story. We don't shove the whole waffle in our mouth. It's harder that way, so we go ahead and take bite by bite. And with division, we use this standard algorithm to go ahead and break things into bites. So I would do 12. The first number is what goes in the house. divided by 3. And as we go further into the next few lessons, having everything neatly and in its right place becomes extremely important. So make sure that you keep things lined up. And I put jail cells, and I highly suggest you put jail cells to lock things in their proper spots. You don't so much need it for a problem like this, but as we get into bigger problems, it becomes very important, especially when we start using decimals. So be careful to get in the habit of doing this very, very carefully and neatly. Okay. So I would just start with my first bite. How many times is 3 going to fit into 1? I can't fit 3 into 1. If I had 3 people, I can't fit them into 1 seat. So I would just go ahead and say so. I can't do it. And then I go ahead and multiply 0 times 3. This is kind of like your proof section here. 0 times 3 is 0. I subtract. And then always check to make sure the remainder here is smaller than your divisor. If it's bigger, then you could have fit 3 into that another time. But in here, 1 is smaller than 5. Once you've checked that, then you can bring the next player down to play the next bite. Okay, so now we just ask ourselves, how many times will 3 fit into 12? And that's just counting by 3 until you get as close as possible to 12 without spilling over. 3, 6, 9, 12. 4 times. And we check it by doing 4 times 3 is 12. Subtract, we're going to get 0. And we have a 0 remainder. We've reached the end of the number. By the way, just keep this in mind. If you do not see a decimal anywhere in this number, it's there. It's just hanging out here, which means it's also hanging out here. All numbers have a decimal. If you don't see them, they're hanging out at the end of the number, hiding in the shadows. So if that's something you can start wrapping your head around now, that will help you later. Okay, this is our first we do. Let's have 3,564 divided by 3. Make sure you copy that down. And let's put it in word problem context. Let's say we found $3,564 and we did whatever we needed to, proper authorities and everything, and then nobody claimed it, so they said, all right, the 3 of you can share it equally. So we had to figure out how much each of us would get. So 3 of us found $3,564, and we're allowed to keep it. So we are splitting it equally. When you are splitting things equally, you're dividing. And we use that standard algorithm we learned way back a couple years ago. 3,564, the first number, goes into the house. And the second number is what we're dividing into it. And it's very important, as I said, to keep this nice and neat. Some people like to use graph paper for this, and you can get graph paper from me if you'd like your notes to be on graph paper so that you can help learn to keep it nice and neat. And if you're able to keep it neat on your own, just by drawing gel cells, you can do that too. So we're going to do this bite by bite. 3 fits into 3. How many times? Well, if I count by 3, I hit 3 on the first count. So the first multiple of 3 is 1. I check it. 1 times 3 is 3. And I subtract. 0 is the answer there. Make sure that that is smaller than that. It is. And when it is, you can bring down your next player for the next bite. How many times can 3 fit into 5? 3 will only fit into 5 once, because if I go twice, it's 6, and that spills over. Remember, it's how far can we get into it to get as close to that answer without spilling over. So 3 only fits into 5 one time, because any more than that will spill over. 3 times 1 is 3, and we subtract. 5 subtract 3 is 2. Check and make sure this remainder is smaller than your divisor, and it is. So once we realize that it is, we bring down the next player. And now we have 26. So we ask ourselves, how many times can I count by 3 and get as close to 26 as possible without spilling over? Well, 3 times 7 is 21. 3 times 8 is 24. 3 times 9 is 27, and 27 is too high. So it's got to be 3 times 8. Knowing your math facts makes a big difference in division. If you don't know them yet, make sure you get to memorizing them. Work on it extra on your own time. 8 times 3 is 24. And we do the subtraction. 6 take away 4 is 2. 2 take away 2 is 0. I don't have to put the 0 really since there's nothing on the other side of it. Check and make sure your remainder is less than your divisor. It is. Bring down your next player, the 4. Well, we just talked about how 8 times 3 is 24, and now I need to get 24, so it's going to be 8 times 3, which is 24, and I get a 0 remainder. Remember that I said every number has a decimal. If you don't see it, it's hiding at the shadows, so there's that decimal. $1,188 we each get. How nice is that? Okay, here's another redo. We have 6,280 divided by 5. Make sure you write that down. And then let's go ahead and put it into the standard algorithm we used to cut that into easier chunks or easier bites. So we could just use our multiplication facts that we know 1 through 10. Makes it a lot easier for us. Make sure to keep it neat. Use graph paper if you need to, or draw nice and neat gel cells to keep things lined up. All right, first bite, 5 fitting into 6. How many 5s can I fit into 6 without spilling over? Only 1, because 1 times 5 is 5. 5 times 2 is 10, and that's way over 6. So that's how I know that. So 5 times 1 is 5. 6 subtract 5 is 1. Check and make sure that's smaller than that. If it's not, you have to go back and fix things. In this case, it is. So I bring down the next number. How many times can I count by 5 and go into 12 without spilling over? Well, 5, 10, 15 is over. 5 times 3 is 15, and that's too high, so it's got to be 5 times 2. 5 times 2 is 10. And I do 2 subtract 0. Oops. 1 take away 1 is 0. I don't need to really put it there. Sorry about my dog barking. Okay. Oops. And we're doing 5 into 28. Well, how many times can I multiply 5 times what and get to as close to 28 as possible? 5, 10, 15, 20, 25, 30. 5 times 6 is 30, which is too high. So it's got to be 5 times 5. And 5 times 5 is 25. And then I subtract. 8 take away 5 is 3. 2 take away 2 is nothing, so I can just leave that off there. I don't really need to put that 0. You can or you don't have to. Only do I put the 0 if there's something else here that's going to sandwich it in, a different number that would sandwich it in, or a decimal. So I could just put the 3. Double check, make sure 3 is lower than the 5, and it is. And once I've checked that, I bring down nice and straight. Remember, I'm keeping things nice and neat. Bring down my next number. And 5 fits into 30 6 times. 5 times 6 is 30. And 30 subtract 30 is 0. Again, if you don't see a decimal in the number, it's hiding in the shadows there. So we do have a decimal there. I just want your brain to start considering that, because we'll be getting into that in one of the future lessons coming up in the next few days. Make sure to keep this neat. As I said, you don't want to be doing, you don't want it to look like this. Don't even copy this part down. I don't want it looking like this. 1, and then 5, and then 1, 2. You've probably seen either your paper or other people's papers looking like this, and then you just lend way for a bunch of mistakes. It goes off this way for some reason, and we don't want that to happen. We want to keep it neat, because it's going to be very, very, very important over the next few lessons, especially, like I said, as we get into decimals, because as soon as that decimal's in the wrong place, the answer is wrong. So if you're putting things above the incorrect number, it's going to be wrong, and I don't want you to get answers wrong. Okay, so now it's your turn. Let's give it a shot and see how we do. We're going to do 2,740 divided by 4. So go ahead and push the pause button. Give this a try. Go as far as you can until you get stuck. Push play so I can help you through, and then you can pause again once you get through the stuck part and try and get all the way to the answer. Once you are either stuck or have an answer, push play. All right, so you have some sort of an answer there. Let's see how you did, or you are to a point where you got stuck. We have 2,740 divided by 4. I'm going to make this 2 look more like a 2. Kind of looked weird. Okay. And I'm going to put my gel cells down to keep things in their place. Hopefully you did that. 4 fitting into 2 doesn't fit at all, so I say so. 2 subtract 0 is 2. Check and make sure this is smaller than this. It is. Bring down the next byte. 4 fitting into 27. 4 times 6 is 24. 4 times 7 is 28. 28 is too high. So it's going to have to be 4 times 6. As close as you can get without spilling over is the deal there. 7 subtract 4 is 3. 2 subtract 2 is 0. Nothing sandwiching in it, so I'm just going to leave it off. Check and make sure this is smaller than this. It is. Bring down your next player. And 4 into 34. Okay, again, knowing your math facts is really helpful here. 4 times 8 is 32. 4 times 9 is 36. 36 is too high, so it's got to be 8, which makes that 32. 4 subtract 2 is 2. Check, make sure that's smaller than that. It is. Bring down your next player. 4 fits into 20. 4 times 5 is 20, so it's going to be fine. And you have a 0 remainder, 0 remainder. So your answer was 685. Notice I took the 0 off the front. Again, same thing as why I didn't put the 0 here. If it's not sandwiched in by anything else, I can leave them off. All right, let's try another one. Okay, it's our final you do for this lesson, 5,034 divided by 6. Go ahead and give that a try. Push pause, and then push play when you've got an answer. All right, hopefully you got further before you got stuck, or you got all the way through to an answer this time. So let's see how you did. We would have 5,034 in the house. Oops, that's 5,034, not 5,035, Mrs. Sanchez. Okay, and divided by 6. And I'm putting my gel cells straight up, nice and neat. Make sure you do it nice and neat. And I'm going to ask myself, 6 fitting into 5. Well, 6 doesn't fit into 5 at all, so I say 0. 6 times 0 is 0. Bring down the 5. 5 is smaller than 6, just barely, but it is. Bring down the next player. How many times is 6 fitting into 50? If I know my math facts, I know this one. If I don't, you can use the grid that's in your planner to help you out too on this. That's fine with me too. But if you know your math facts, you would recognize that 6 times 8 is 48. That's pretty close. 6 times 9 is 54, which is over. So it's got to be 6 times 8, which is 48. Get those math facts memorized if you don't have them already. Makes everything easier. 10 subtract 8 is 2. 4 subtract 4 is 0. I'm just going to leave that off. 2 is smaller than 6. Bring down the 3. 6 fitting into 23. 6 times 4 is 24, which is just a bit too high, so it's got to be 6 times 3. So 6 times 3 is 18. Subtract, I've got to use my borrowing skills. 13 subtract 8 is 5. And 1 subtract 1 is nothing, 0. And check and make sure 5 is less than 6. It is, just barely. Bring down. 6 into 54, if you know your math facts, you know that 9 times 6 is 54, or if you're using your grid, you would have known that 9 times 6 equals 54. So that's exactly the number we need. 9 times 6 is 54, with a 0 remainder. Our answer is 839. Hopefully you got that correct. That's the end of this lesson. If you're understanding it just fine, go get the closure questions to prove to me that you're able to do this. If you're still unsure, you can rewind to any part of this lesson and listen to it, the explanations again. And if that doesn't help, please come see me so we can practice a few together so that this clicks into your head. You want this to be very well known, and you want to be very comfortable with this before we move on to the next lesson.